Well, the classic is, the classic tech support is, try turning it off and turning it back on, And it's funny, when the one job I worked, actually the job that I worked with the guy that I was talking about before in the flannel shirt, when they were shorthand with technical support, they would have the programmers do it, and the programmers hated doing it. So we did it just so that we wouldn't get fired, but our heart really wasn't in it. But we would work in 1 or 2 hour shifts. So the classic, and this was the old days when people were on multi-user machines, so it wasn't like a PC where you could reboot in a second. So you had to notify everyone to get off the machine, wait for everyone to log off, then reboot it, And so that was the classic. It's if someone called with a problem, you'd say, well, try restarting your machine. The thought being one of two things. Either it would work, right, and you'd be a hero, and they'd be like, oh, thank you, you're so brilliant. Or it wouldn't work, and by the time they called back to tell you it didn't work, your shift would be over and some other person would have to go and figure out what to do. So I'm not proud of myself. I'm not saying this as a bragging thing, but it is what it is. All right. So far we have sort of conceptually covered a good portion of this class, believe it or not. And again, keep in mind conceptually. That doesn't mean that we're going to be ramping things up next week. All right, we've covered the way that ASP websites work, specifically using the web form model. All right, depending on how the semester goes, we may look at another model towards the end of the semester, but for right now, we're covering what's called the web form model. And what that basically is we have a client requesting pages through the internet. Those requests get sent to a web server. The request contains a bunch of stuff, the URL, any form data, IP address, platform, a bunch of other stuff. In the case of an ASP.NET website, the web server takes, and that request is going to translate to an ASPX page. Which is basically an HTML plus page. An HTML plus what? Plus ASP.NET controls. Those ASP.NET controls have properties. And we can set those properties in the Visual Studio tool when we create it. We can say, for example, our calendar we want to have starting on Monday. The first day of the week being Monday. We then have C# code, which can access and manipulate the properties of these controls, therefore customizing the page based on the user's request. In the example that we saw, we had a calendar, which is an ASP.NET control, which looks like an HTML tag, but isn't. All right. It gets translated by the server into HTML, CSS, and JavaScript. All right. And we had code to manipulate that based on a couple of different things. We had buttons that would show and hide it. We had a drop down that would allow us to pick what day of the week was the starting day of the week. Is there any questions over that example? All right. I'm not going to show that example again because I'm tired of calendars. All right, and if you don't have any questions about it, we probably will just move on to the next topic. Do review it, though, and make sure that you understand what's going on with it, because conceptually, that's a good part of the class. All right. Now, what are we going to do? Well, we're going to learn more ASP.NET controls to allow us to do more stuff, and then we are going to cover more C# stuff on how to do the programming and how to have the program that we write in C# interact with those ASP.NET controls to do what we need to do. All right, here's the example we're going to start with today. All right? And we're going to do this example in pieces. Why? Well, I think it's a good teaching strategy to not just dump everything on you all at once, but to sort of build a solution incrementally. So I think that's a good teaching strategy. It's also a good programming strategy. All right, and it's a good strategy for a number of reasons. First of all, if you try to do everything that you're supposed to do, all right, if it works, great, you're done. If it doesn't work, then you might have a hard time finding your problem because you're looking for your problem in a whole bunch of code. All right, you're looking for your problem. Problem could be in any number of places. So if you have 100 lines of code, it's harder to find your problem than if you have 10 lines of code. I mean, it's just basic logic to figure that out. Therefore, it's best to do programs incrementally. And this is how I program for real. If I have a programming task, I almost never try to do the whole thing all at once. I do a piece, test it, get it working, add something new to it, test that, get that working. Because each time, if it stops working, then there's a good chance that it's the code that I added that broke it. Not always. There might have been sort of a latent problem that you didn't notice quite yet. But most of the time, if you build incrementally, you're just looking at the chunk of code that you just added a minute ago. So it's a lot easier than looking at a whole string of code. So it's easier to code that way. And again, from just a human factors thing, it's better to get 50% of your program 100% working than 100% of your program 50% working, if you know what I mean. It's better for your attitude. In other words, you can look at it and you can end the day and say, well, I made it this far on this program. I didn't get it all done, but the part that I got done works. All right? And as such, you're in a better position. This is better for your attitude than to have a big chunk of the coding done, but absolutely nothing works, and you don't get any positive results. Then you can pick up and work. Then you really don't know where to go next if you take that approach. So here's a problem that I want to solve. I'm going to be helping someone move soon, and we're going to actually Saturday. So we need to rent a truck. All right. So I'm going to create a simplified version of a calculation to tell me how much it's going to cost to rent a truck. This could be at U-Haul's website or whatever. I'm going to tell you ultimately what we want. And then we're going to build it piece at a time. All right, we're not going to try to build the whole thing. All right, if you ever rented a truck, it depends on the size of the truck, how much it is. All right, bigger truck, the more costly it is. It depends certainly on the number of days that you have the truck. So if you have it one day, it's a certain amount. 2 days, a certain amount, and so on. It's going to be rate times, the rate for the truck times the number of days. In addition, you get charged so much per mile. All right? So, let's say, here's our business rules. And again, I kind of looked into the pricing of this, but my pricing probably isn't going to be accurate. Just pretend that it is. All right? Let's say you have 3 choices: a small truck, a medium truck, and a big truck. And let's say it's 20, 30, and 40 for these. All right? Let's say it is, and this is per day. And then let's say it's 75 cents per mile. Love the sound effects. form is going to look like here. All right? Actually, I could have a text box for how many days, and then that might be a good idea, but I'm going to have a text box for pickup date and return date. All right, starting out. Going to need a text box for number of miles. What are we going to put on the form for the size of the truck? Could be a drop down. What else could it be?
Radio button.
Radio buttons. Which is a better choice?
Personal preference.
Largely personal preference. All right. The only thing I would say is the one thing that sometimes will tilt me one direction or another is how many choices that we have. All right. So if we had the states in the United States, you could use drop downs or radio buttons, but there's 50 states, right? So 50 radio buttons would kind of be take up a lot of space, whereas a drop down would be better for that. An advantage of using radio buttons is you see all the choices all at once. You don't have to scroll through a list of choices. So we can do this either way. I'm going to pick radio buttons for the sole reason that last week or last class I used a drop down. So just to get some variety, I'm going to pick a radio button for size of truck. Then we're going to have a button that says go ahead and calculate the amount. Alrighty. Validation. What kind of validation? Name a validation that we would need to perform on this form.
Dates.
The dates. What about the dates?
Make sure you're not bringing it back before you pick it up.
Right. So, number one, make sure that the return date is not less than the pickup date. That gets into all sorts of bizarre physics implications of time travel and quantum gravity and all kinds of stuff like that. And at this point in the class, we're not prepared to do that. Just kidding. Right? What else? Yes?
Usually don't pick a date that's already gone by.
All right, that's a good one. Make sure they have not picked a date. This is assuming that this is like at the end and the thing has already happened. All right, so you're right. As opposed to, like if this was meant to like plan how much it's going to cost, then maybe you could say it next weekend. But that's a good one. Make sure that these dates are not in the future. Okay, that's a good one. Didn't even think of that one. Yes?
Make sure that they put numbers in the miles.
Make sure that this is a number. What else? Okay, make sure that they pick the size.
Also make sure that when one size is picked that it's not charging another rate.
Okay, that's not validation per se. That's making sure our program logic is correct. But yeah, we will want to test that. We will want to test to make sure that our calculation calculates the correct rate for the option that's chosen. Yes?
Also, how would you put your date in there? Would you do it by like writing the date out, the person, or would they have to do it by number?
question. The good news is that you have some flexibility as far as that goes, but that does bring up a good point that you have to put in the date in, you have to enter some form of a valid date. So make sure that this is a valid date format. Here, I'll put that over here as well. I can think of
Number of miles cannot be blank.
number of miles can't be blank. In fact, we can say that for all of these. We said it for this. Can't be blank. There's one more thing I can think of. Yes?
When you hit calculate, if they left something blank, it would give you the error message.
Correct. Correct. And again, all these things will work that way. That if you put in something and that didn't meet one of these validation rules, that it would give you an error, and hopefully it would tell you specifically what the error was, and not just error inputting data or something, some generic message. But it would be very specific to tell them.
We should leave out the other things, that way they can get money off.
Pardon me?
So we should leave out the other things, that way they can get money off.
What do you mean?
Like if they do negative, that way we get money off.
Exactly. Exactly. So how we handle that with dates by saying the return date can't be less than a pickup date. That way you can't have the car for negative 5 days. We also need to handle that with miles. So you can't say that you drove backwards for 50 miles and get 75 cents off your bill. So this number can't be negative either. Actually, now that I think about it, I'm not going to change it now. Well, I probably should. Maybe this will be a revision. Should I put in number of miles? No, I probably should start beginning. I should probably allow the entry of beginning and ending odometer reading, right? Because, yeah, let it calculate it for you. That way, less prone to math errors and so on and so forth. But I won't change that now, all right? Just like I could enter in number of days, but it's probably better to do that calculation. All right? Now we're going to do this a piece at a time, as I mentioned. The first piece that we are going to do, we are going to not worry about the dates. We're just going to assume they had it one day, right? Why am I doing that? Because I can get started and get something done. I know that I have to go back and do the calculation for the number of days. It's not like I'm trying to cheat or slip through or something like that. But it's better to do things incrementally. So I'm going to get this piece of it working. And I'm going to assume that there's one day. It's one day. All right? And then we'll go back and we'll add the logic for calculating the number of days. Now, if you do this cleverly, all right, using what are called stub functions, you can do this in such a way that it's very easy to go back and change. All right? So we'll look at doing that. Again, one of the things in this class and in all the classes that I teach, my aim isn't just to solve the problems that we're discussing in class. My aim is to talk about good programming habits and good programming skills to have. All right? So the question isn't just how to do all these things. I mean, that's important. But the question is developing a good methodology for developing code. A good procedure for developing code. Because that'll be, if you pick up good habits, that will be very, very beneficial to you. Writing code can be hard, and the bigger the program is, the harder it becomes. Therefore, it's good to sort of have a systematic approach instead of just haphazardly trying stuff until it gets to work. All right, so let's go and let's make this happen. Someone could get the lights? So I'm going to go up here, File, I'm going to create a brand new, we're not going to start with that old example we had last time. File, New, Website. Going to create an empty website. I'm going to put it on the desktop. And I'm going to call it Zeller's Rent a Truck
Company.
Yep. I'm going to use Visual C#, putting it there, empty website, click OK. And away we go. Now again, do realize that this is a case of do what I say, not as I do. I'm not going to pay too much attention to the way the site looks, the way the page looks. All right? That doesn't excuse you from doing that. All right? You need to go and dot the I's and cross the T's and make this look like a completed web page. Doesn't necessarily have to be elaborate or a masterpiece, but take some care in the design of the page. All right, so I'm going to go up here, File, New, File, and I will create a web form. I will call it default.aspx. You should have one page on your site that's called default.aspx. That's your home page. Again, using Visual C#. We definitely want to put the code in a separate file, so we want that checked. Master page we are not touching for now. All right, so I click Add, and away that I go. So I'll go in and I'll put an H1 for Zeller's Rent a Truck Company. Then I'll go in, and again, it's good if you are able to use both the visual and the code window. I switch back and forth between them. All right. Don't strictly use a visual because there's some things you ought to be able to code by hand better than using the visual. All right, there we go. Standard. I'm going to pin that guy up here. And I'm going to pull over 2 things, 3 things, 4 things. I'm going to pull over a number of things less than 1,000. All right, I'm not really sure. What do we need? Let's take inventory. I need a text box for the number of miles. I need a label to say what that text box is. I need a label to say what the next thing is, which is going to be a radio button list. All right? Notice that your options are radio button and radio button list. Typically, you want to create a radio button list. All right? Because you don't just want a single radio button. You want a list of radio buttons. And you want those radio buttons to be connected together so that when you select one option, the other options are unselected. So if I clicked on medium for the size of truck and then changed my mind and decided I wanted a large truck, when I click large, it should unselect medium. So you get that functionality by making a radio button list. I'm going to want a button. And I'm going to want a label to hold the results. So my calculation is done. I want to have the answer. Now, I'm going to go and edit some of these things. All right? So, I'm going to change that label so that the text of it says number of miles. I'm going to change this to have the text say size of truck. I'm going to have this button say calculate bill. I'm going to have this label initialized to nothing to start out, because I don't want anything there until we've actually calculated the amount of the truck. All right. Now we notice this. Notice that that is still not correct. It says unbound. Unbound means it's not connected to the database at all, which is okay in this case because we don't really have a database. All right, but at some point our radio button options might come from a database table. So for example, if we were to do a college database and we had radio buttons for major, all right, or a drop-down for majors, there might be a table of majors that we would use to populate this radio button or drop-down. Now, radio buttons and drop-downs work about the same way. If you remember last time when we created a drop-down, we clicked on the little arrow and we got to add items to the drop-down. Radio button's going to work just about the same way. All right, so I'm going to click on that. Choose data source would be if we were using a database. Edit items is where we're going to put those items in. And there's even enable auto postback. If you remember, we used that feature last time. And if you read between the lines here, and especially if you've had advanced C# or other advanced programming classes, you'll see that radio button lists look a lot like drop downs. Well, that's because they kind of are the same thing. All right. It's just the manner in which they're displayed. So in object-oriented terms, they both come from a common ancestor. They both have a superclass at some point in common. So anyway, I'm going to click on Edit Items. I'm going to add my 3 items. Small, give a value of S. Medium, we'll give a value of M. And large, we're going to give a value of large, or a value of L. Now, notice that we can orient it that way, vertically, or I can look at the properties for the drop-down and orient it horizontally. So whatever makes sense. These are all properties that you have. Now, I know I said I'm not going to spend a lot of time on appearance, but I am going to clean this form up a little bit. All right, simply because right now it is almost to the point of being unworkable. All right. So I'm going to go here, and those of you who've had me for CISS243 know that a form is really simply a list of form controls. So I'm going to make a UL. I'm going to make an LI, list item for each of these things. I'm going to do like part of the job, and then we'll finish it up later. Maybe, if I remember how to type it all.
And why is it again that you do it individually? Why isn't that you don't do it for the whole?
Repeat that, please.
You start with your LI up in your left-hand corner, and then you stop it again after the text box. And you start it again, and then you end it again. Why isn't you just have one?
Well, I don't want one list item, then they'd all be in one line.
Okay.
I want each form item to be on its own line.
I have a question.
Yeah.
And like last week, we can change the title label to on this page as well as on the design view on the side box, correct? Right?
Repeat that, please.
We like where it says label 1, label 2.
Right.
We can rename them on this page
Yes.
as well as the other page that we had.
Yes.
It doesn't matter, right?
Correct.
Okay.
Now, so now we go back on this in design view, and we notice that it's lined up that way. All right. Now, a couple of things that we might notice that we still don't like. Still doesn't look terribly pretty. I don't like the bullet points and so on. We'll leave them in for now because I think we have bigger fish to fry. But later on we can play around with the CSS and make the form look at least a little bit good. One thing I do take advantage of in this class is a chance to sort of revisit some HTML and CSS stuff. All right. Now, I'm going to go and I'm going to change the name of this to change the ID of this to TXT miles, and this to RB size. Now I didn't go and change the name of the labels. The labels are just label 1 and label 2. All right? I certainly could go and change the labels to label miles, label size, but I'm not terribly worried about that. Why do you think that is?
Because you're not using them in the code.
Because I'm not going to worry about coding those things. All right? So it's most important to get the label or get the ID correct for things that you're going to write code for. All right? If it's just a static label that says number of miles and it's never going to change, I don't really care if it's called label 1 or whatever, because I never have to refer to that. All right? Whereas the text box for miles, the text or the radio button for size of truck, I am going to go back and program for. Just like this label I am going to put in code, right? I'm going to put the value that I calculate here. So I am going to give it a name. Yeah.
How come you didn't make that a text box?
Can they edit their bill? No. You can't edit the bill, right? I mean, if it does a calculation and it says you owe $57, you owe $57. You know, you can't go back and type something over in.
I guess I just think of a label as just like how we had numbers of miles and the size of truck. I think of that as that's there, and that's it.
Okay. In general, I would say labels are for text that you can't edit, whereas text boxes are for text that you could edit. Now, you could put it in a text box and disable that text box, but that seems more trouble than it's worth. All right, just use a label. All right, so we're ready here to do just some basic calculation. All right, so let's go in and let's do the basic calculation. All right, so I have my button click event here, and remember I said we're going to assume to start out that number of days is 1. Okay? So I'm just going to hard code it as 1. Is that something you can leave in your code? Absolutely not. You're going to have to change that at some point. But for now, because we're assuming that the number of days is 1, we can hard code it. All right? It probably would be good if I put a comment in there to tell myself that. Or like, for example, if I were to be going on vacation and someone else were going to polish this off, right? They would look and say, oh, okay, this is just number of days, you know. So I'm going to be a good programmer, and I'm going to put a comment that says hard code. This keyboard is messed up, or I don't know how to type.
It's a keyboard.
You can take it and break it in half and get a new one.
Okay, so I want to grab the number of miles. And I want to grab the size and determine the rate. Where am I going to get the number of miles from? The text box. So what's going to be the syntax for that? The name of the text box. Okay. Is txt miles enough? No. Because the text box is, again, an object. It's a component. It has a whole bunch of properties. The color of the text, the position of it, a million different things. So remember, when you refer to an object, you have to refer to what's specific about that object you're interested in. And we're interested in the text that's contained in that object. And so we'll say .text. Now when we do this, notice we get a red squiggly line. Why do we get a red squiggly line? Because what?
Because you did it wrong.
Because I did it wrong. Okay. Specifically, what did I do wrong?
You can't, a double is a form of a number.
Right.
Text is text and they're not the same type.
Yeah, exactly. A text box contains any sort of text. Now we know that this text box, we're going to force them only to put numbers in. But in HTML, the HTML that this gets translated to, a text box can contain any text. All right, therefore there could be a string in there. And therefore we could try to take a string, someone's name, or random letters, and try to make a number out of it, which it can't do. And it knows that it can't do that, so it tells us this. This is a good kind of error to get, right? Because this is a sign that something is wrong, and we have to correct it before we can run this. So how do we correct that?
Parse it.
And what's the syntax for that?
Parse it too soon.
Double that first.
All right.
Unless you want to try it.
This is one of those cases where I'm keeping it ambiguous as to whether I am testing your remembrance of your intro to C#. All right. Or if I'm demonstrating the need to be able to quickly find resources, or if I really myself don't remember how to do it. So I'm going to go up here and Google C# convert string to double. Use a to double, convert to double. It's a conversion and fails. If you prefer not to handle exception if the conversion fails, you could use double.parseString. At some point, we're going to know it's going to be numbers only. Right now, we don't know that, but you're absolutely right at some point. So we can use one of those two methods. Actually, in this case, all of the above was true. I wanted to see if you guys remember. I wanted to show the need to be able to quickly find resources and use the resources. And I myself couldn't remember how to do it. All right? You could just start typing and hoping that you hit the right thing, but not always most efficient. So we have the number of miles. Now we have to determine what the rate is. So, how do we determine that? We can determine that through either a case statement or a series of if statements. We'll do it both ways. If radio button size. Again, is that enough to say RB size? No, because the radio button is an object. It has a whole bunch of properties. You know, we saw some of those properties, the orientation, whether it's vertical or horizontal. All right, and there's a whole slew of other properties as well. We're interested in the property of which thing got picked. And reinforcing the common ancestor theory that I proposed before, selected value is the same thing that we use for dropdown. All right, that indicates the value of the thing that was selected. So, if that equals S, then what's my rate? Rate equals, I think I said 20, right?
Why wouldn't you use the 0 in this?
What do you mean, why wouldn't I use the 0?
You remember how it had the 0, 1, 1?
Okay. That's a different property
Okay.
of it. That is the selected index property. And I could write this code to use 0, 1, or 2. I could say if selected index equals 0,
Okay.
if selected index equals 1, selected index equals 2. Now, why do you think I didn't do it that way? Because I deliberately didn't do it that way. Why do you think I didn't do it that way? Yes?
Because at a glance, you want to be able to tell which is which in the code.
Number one, it makes the code a little less readable, because then it's like, what was 0 again? And then there's another sort of reason. Let's imagine that the head of marketing says, we want to encourage people to rent big trucks. So we're going to change the order of those radio buttons to put big first. If you put big first, if you rearrange the orders of the UI, you'd have to go and change this code. As it stands now, I could rearrange them in any order. It's not looking for the position. So this is, again, using, trying to separate the way the UI happens to look with the actual values of it. I've said sometimes that being a good programmer is in part, inspired laziness. All right. In other words, you do things for good programming practices because you don't have to spend a lot of time making changes later. So it's easy to make changes. So you don't have to do too much work if you change things. And we'll go and do this. So, what is my cost? My cost equals rate times number of days plus number of miles times 0.75. Why does rate have a red squiggly underneath it? I spelled it right, amazingly enough, after my bad typing in the goofy keyboard. Why does rate have a red squiggly line? Yes?
Is it because rate's a double and number of days is an integer?
No? No, that's legit. You can do that. Yes?
Is it because you declared it inside of if statements?
You're more or less right. In other words, if you look at this code, the compiler looks at this code, let's put it that way, and it imagines, what if I had a value that was an S, was an M, was an L? We could make it all the way through these statements, all right, and rate could be undefined. Thank you. And the compiler knows that's not a good thing, right? Now, we know that it can't be the case, right? We know we've rigged the deck so that this is a radio button, and we can only pick one of these three. And later on, we're going to put validation on it to make sure that you pick one of those three. But the compiler looks at this and says, hey, it's possible that I could make it through these three if statements and not have a valid value for rate, in which case this would blow up. So again, this is a good thing for you. It's best to catch errors at compile time and not run time. All right? So the compiler pointing out the fact that there could be a potential problem is going to save us if someone, for example, later on went and added an extra large truck. And, there would be no value then for the rate. So we can get around that simply by putting in a dummy value. It equals 0 we could do. It really doesn't matter because, again, we're going to make sure that we're going to make sure that the size has a legit value. So therefore, we really don't need to worry about that, but the compiler tells us we have to worry about that, so we do. And now, magically, the error goes away. All right. So, now what I want to do I've just calculated the cost, right? We have to put that cost somewhere on the screen. So I'm going to put it in the label. LBL results. Again, dot text equals, can I just say cost? No. Why not? Same. Go ahead.
Because it's a double.
Because it's a double. Same thing. This is one of those things that's like sort of maddening, that you look at this and say, well, it should be able to figure that out. Well, the compiler is doing these things for your protection, all right, and it's best to find problems like this at runtime. Rather compile time rather than runtime. So what do we need to do? We need to convert this to a string. How do we convert to a string?
Dot to string.
.toString.
And you put a C in there and make it currency.
Excellent. All right, so let's run this and see how it works. Now, do keep in mind that we've made some assumptions at this point, because we're doing this incrementally. We're not trying to do everything. We know that parts of this don't work. We know, for example, that if we don't choose a size, that we're going to get some goofy result. Or if we don't put miles in, we're going to get a goofy result. Or if we put in words for miles, we're going to get a goofy result. So we know we have to go back and do those. So number of miles, we'll say 233. Why am I picking such hard numbers? Let's pick 100 miles. So how much should that be? That'd be $75 for that, right? Plus $20 for the small truck. That should be $95. Yay.
Sorry.
Wow, that's great. I like this.
Perfect timing.
Medium. Is that correct? I think it is. 30 plus 75, yeah, and then large. 115. Now notice, as was mentioned before, if we try to get smart and put a negative value in here, we get a $110 refund.
Very nice.
All right. If we put garbage in here, boom, it blows up. All right. Because it can't possibly take that and turn it into a number and so on. So we know we have our limitations, but we've gotten through the first part successfully. Now, one thing that I encourage in this class is proper testing. All right. If you think about this, this is a very, very, very simple page that we're creating. All right. But if you think about all the things when we get done that you would have to test, you're going to have 20 test cases. All right. You're going to have to test, first of all the validation that we put in. What happens if I don't put this field in? What happens if I don't put that field in? What happens if I put a negative net value in for this? What happens if I put a starting date that's after the ending date? So really, to thoroughly test this, you want to cover, I hesitate to say all conditions, because all's a big word, but you want to cover as many possibilities as you possibly can. So really, in this case, since I haven't done any validation, really, there's 3 test cases. Test for small, medium, and large. All right? But I wouldn't just test for medium and say, yeah, it did that one correct, we have a winner. All right? I would test the other two as well. And as we get more and more involved with this, we're going to have to test validation and other things as well. Now, if we start adding more complicated business rules, like maybe like if you have it over a week, you get a 10% discount or something like that, then our test cases will skyrocket again. We'll go even further. It's good to have a test plan. A test plan is where you actually document all the different things that you're going to test. All right? And you specify what you're going to put in and what you're going to get out. All right? One reason that that's good is that helps prevent what's called regression errors, to test for regression issues or regression errors. Regression is where something that used to work stopped working. So, for example, let's say we had this page up and running on our website. We go in and we add an extra large truck as a possibility. Does that mean that we just test the extra large truck? No. You go back and retest all the other stuff that happened before to make sure that that stuff didn't stop working when you added the extra large truck. So it's good to document the test cases of all the possibilities of things that you want to test to make sure work correctly, so that people later on can pull up the test plan for this page and retest it if they make any change to the page itself. All right. Let's go and add some validation to this. And this is actually really cool. There's a whole slew of validation controls. And we'll go over some of them today, and some of them we'll go over next time. All right? The first validation control we're going to have is a required field validator. A required field validator does exactly that. It forces you to enter a value for something. So I'm going to go and I'm going to drag that over, and it's a required field validator. Now, when we create a validation control, we have to specify, again, some properties of it. First of all, we have to specify what control it is we want to validate. In this case, we're going to validate txt miles. Right? We can have 15 text boxes on the screen, right? And maybe 8 of them are required and the rest of them aren't. So we can't simply slap a required validator on the page and have it expect that it's going to validate the right thing. We have to tell it the right thing to validate. We also have to go and specify the error message. What we want to say in case it's an error. And what do we want to say? Something like must enter miles. So now I go and run this. I click Calculate Bill. I still get an error. You guys need to get the sad trombone sound for when I try something and it doesn't work.
I have a cricket sound.
Well, that might work too. Nice. Interesting. Yeah, I didn't see this error message the first time. Maybe I just clicked refresh or something. All right. this is a pain, but it's an easy correction. All right? What it's telling you is that there's different ways that you can configure your validation to work. By default, it thinks that we are going to be using jQuery for our validation. We're not. Therefore, we have to put something in the ASP.NET config file to tell it we're not using jQuery, that we're using sort of the controls. And this is where I have a beef. jQuery shouldn't be the default. All right? The default should be to do it the old way. And maybe it's an issue of how Visual Studio was set up on this particular machine. But I'm going to go and Google this big old error message, and it will tell me what I need to do. I simply need to add something to the ASP.NET config. And what I need to add is that. So I go and add this to my config file.
Don't forget to stop debugging.
While it's running, I won't. Exactly. Go and add this to my config file. And I should be back in business. I don't get the error. I know you guys are sitting there waiting with your finger on the trigger for this to mess up again. Sorry to disappoint you, but I'm pretty sure it's going to work. I click that, and I get the error message saying. All right. Bottom line. I don't know what just happened there. I think I bumped the mouse or something. There we go. So the bottom line is to do validation the way we are doing it, add that configuration, add that entry to the configuration. I would call this a problem in Visual Studio because if you were to take, if this issue happened at the .NET Framework 4.5, my idea on applications when they upgrade is they should always by default implement the old behavior unless you say you want the new behavior. That way there should not be problems converting an old application to a new format. And if you want to add the new behavior, it should be a deliberate thing that you add on. This forces us to use a new behavior unless we go and ask for the old, so I don't know. I don't like the way it does that. But bottom line is you can simply pull down my copy and pull that app settings. All right, we're on a roll now. All right, I have a few minutes left. We can add at least 2 more validation controls, and then we'll call it a day. Next one I'm going to add will be a validation for the radio button. And that will also be a required field validator. And I will specify for that validator must select size. I don't think I can blame the keyboard for all these problems.
I don't know. It was pretty bad for that keyboard.
You can use my keyboard.
His keyboard's cool.
I was saying, could I use the keyboard with the flashing lights? Ooh. Control to validate RB size. And that'll make sure that we have picked a valid size. Because a radio button, nothing is selected by default unless we choose to select by default. you should select defaults based on what makes sense for your particular problem, not for your convenience as a programmer. So for example, I could put a default on here, then I wouldn't have to worry about validating. But that's not really a good reason to validate to put a default on here. Now if I knew that most of our customers chose a medium truck, then I could make that the default. And so as it is now, if I put that in, those two error messages go. If I select, then it does the calculation for me. All right, the last thing I'm going to do is, we still haven't put validation in for this. If I put garbage in. Because all the required validator does is make sure that something is entered there. All right? So, it's still going to blow it up. So what do I have to do? I put in a compare validator. This is a little confusing because you use a compare validator for a couple different things. One of the things that you use a compare validator for is to validate that like one number is greater than another number. So like when we put in the two dates in this example, we'll use a compare validator to compare that the starting date isn't after the ending date. But we also use a compare validator to compare if a value is of a certain data type. So I'll pick compare validator. I'll put in as my error message, must enter a number. And then I'm going to say control to validate is text miles. The operator I'm going to use is I'm going to use a data type check. And the data type is a double. So now when I go and run this, tells me that they must enter a number.
What is that double stand for?
Double is a data type. Essentially, is a number that can include decimals. Google C# double, and it will tell you more details about it, like what the biggest number is, what the lowest number is, and so on. Now, still have the problem we could enter a negative number, right? That's our cliffhanger for this week. All right. See if you can download this example and see if you can figure out how to keep it from entering a negative number. All right. We'll pick up on this next time. We'll add some functionality and add some validation to it. All right. Questions? We'll see you in lab. I will do like I normally do. I will go unlock lab. Then I will come back and get all my stuff, and I'll be back in lab.